Welcome to Openshift Serverless demo. In this demo, we will create a REST service using Quark's application framework. And then we will build the REST web service locally, run it. After that, we'll package it, deploy it on top of Openshift using the serverless platform. So this is the REST API, a simple API with an endpoint to calculate the net salary using a query parameter of, again, gross salary. So we start Quarks in a dev mode. So Quarks already started. And then we hit the URL, get the response. You can also test the same from the browser. So now let's package the Quarks application. And this is just a lightweight jar where we have only the application classes. So to run it, we definitely need to use the Quarks run jar file. We test the application again. Now let's package the application, but using the Uber jar, where the application along with all dependencies will be packaged inside the jar. So now we can test the application working again. The next step is to quickly deploy it on top of Openshift. The first and easy way of deploying it is to just upload the generated jar. So upload the jar file directly to Openshift, and then just change the name. And this is a base image, definitely the OpenJDK 11. Change the name as well to serverless, and choose the deployment type to be serverless deployment. And for this, the knative service will be created along with all the objects required for our application, including the deployment object, the service object, the route, and the definitely the build configuration that will be used to build our container image. Here we have the build, it's running. We can look at the logs. So the first step definitely is to upload the Uber jar file representing our application, and then get the base image, and then definitely copy the jar file to the right path, and finally create the image layers and produce the application image and push it to the internal image registry. So let's look at the serverless knative service. This is the route created. We'll just wait for the bot to start. Now the bot started by clicking the route. Now we can see the home page. If we access the REST endpoint salary with no query parameters, this is the response. If we provide the growth query parameter and give it try, this is the value. So if we wait for a while, what will happen? The bot will shut down, so terminating the bot. So now there is no running bots at all. And if we go back to the page and refresh, hitting the REST endpoint again, what will happen? Immediately serverless will start a new bot. And we'll see that again using the Quarks, the startup happens so quickly. So, and now we have the page with the response again. So let's do one more thing. Now we uploaded the source code to a public GitHub repository. So we have the source code under main, the serverless Java class, and this is our REST implementation. This time, what we will do, we will use the Openshift S2I to build the container image directly from the source code. So let's build from Git. The moment the Java was detected, the base image is also retrieved, and then we selected the serverless, and now we're adding the Maven arguments to build the Uber file. So because what is happening, the S2I engine now will use Maven to build the Uber file, and then jar file, and then add the Uber jar file to the application image on top of the base image. So if you look at the build this time and quickly check the build logs, the first step is cloning the source code, definitely from the GitHub repository, and then finish the jar file build. The serverless runner Uber file was generated, and then the base image, and adding all the application image layers, and then finally application image was produced and pushed to the internal registry. If you go back to the application and wait for the pod to start for the first time, here the pod starting. Now it is running. If we click on the route and look at the pod, this is the pod already started, hitting the REST endpoint /salary. We're getting the response, then we can add the growth query parameter and get the response. So now if we look at the surface, the calculations actually are done based on what? 80% of the gross. So the net salary is 80%. So let's now build a new version, or what's called a revision of this knative surface. So first of all, we'll check the generated image stream. So this is our image stream under demo 02 project. So let's tag it now. So we'll take the latest tag and tag it with V80, representing, for example, the 80% formula, right, for calculating the net salary out of the gross salary. So now the new image stream tag was created, and accordingly we can edit the knative surface, and in the deployment container image we can simply change it from, yeah, so there is no even the latest, we just add the new tag which is V80. So when we say save, automatically a serverless revision, knative surface revision, will be created. Look at this, revision 1, revision 2, okay, and hitting the URL definitely will take us to the revision 2, which is the latest. Good. So now let's change some logic. Let's play with the formula, and instead of having 80% growth, we will take the 70% growth. So we save the changes, and then we committed the changes to the repository, local repository, and finally let's push the changes to the public repository. So what is required now is to trigger a new build. So go back to Openshift. Just make sure first that the changes are reflected on the repository. So if we go to the serverless file, you can see now it is 0.7. So let's trigger a new build now. So we come to the build and start build. So now a new S2I source strategy build is triggered, cloning the repository from the GitHub, and accordingly build the Uber jar file and build the application image and push the application image to the internal registry. When we push it every time, it actually gets the latest tag. Okay, so just wait. Yeah, I think the build now is complete. Very good. Okay, so now let's tag this image with a new tag, which is version 70. So after we build the new image, we tag it to 70. Now let's go back to the knative service and edit it. We'll go to the container and change the version from 80 to version 70. We can see that the third revision is created. So we have revision 1, 2, and 3. Let's now split the traffic and get 50% of the traffic to revision 3, the other 50% going to revision 2. The moment we save, immediately revision will be added to the route, and by hitting the URL of the route, now the request went to version or revision 2, and we are assuming again 80% formula applies here. Yes, we're getting the 80%. If we hit the URL again, so this time the request goes to revision 3, we're getting the 70%, and if we continue, the traffic will be again split between the two revisions. So now if we go to the service, the knative service, and look at the manifest file and look at the traffic section, we can clearly see that the traffic split between two revisions, and the percent is 50-50 between revision 2 and revision 3. Let's do one more revision. So we'll go back to our service and change the formula for calculating the net salary, bring it down to 50%. Okay, we need to save and again add the changes to the local repo, commit the changes 50%, and then push the changes to the Git repository. We will go back to our repository and we can see that the changes are reflected. So again, one more build. So we go to the build configuration, start build. The same process of building the Aubergine and building the application image. So we need to tag this image stream again, and this time the version will be version 50. So the image stream tag is created. We edit the knative service, change the image tag to 50, and accordingly a new revision will be created. This time it will be revision 4. Okay, so it's not shown here, but it's view all 4 revisions. But again, if we hit the URL, nothing changed. Still, we will be redirected either to revision 3 or revision 2 because we did not change any traffic distribution rules yet. So as we can see, one time it went to revision 3, the next request goes to revision 2. Okay, so now there is a new way of sending the traffic to a revision by providing a tag. Okay, and just we need to add 0 split. Okay, we will keep the tag, which is pilot, and then we add just 0 split. So looking at the traffic distribution, we can see that it is still 50%, and there is 0% goes to revision 4. But the unique thing about revision 4 now that it is tagged. So if we hit the route URL, again, we will either go to revision 3 or revision 2. There is no way yet to hit revision 4. So one time we went to revision 3. If we hit one more time, right, let's see, still revision 3. Yes, I think this time, yes. So now this time it hit the revision 2. But as we can see, we are not able yet to access revision 4 because simply the traffic is 0. But if we just have a look, we will see that there is a route created for this revision using the tag. So you can see that pilot now was added, the revision tag, to the route URL, and we will be able to access this revision using this specific route. So if we hit the route with pilot, immediately the container will start and we'll be getting the response from revision 4, which is, again, we know that it will be 50% formula. So yes, we're getting the 500. So now the question is there any other way we can access the this revision using the standard route URL? Yes, using the HTTP headers. So let's now use the route URL of the knative service, not of the specific revision pilot. So again, this is the pass salary, and we come to the HTTP header, and we provide this header, the knative serving tag, and we just provide the tag of the revision, as simple as that. So let's have those number of threads and the loops 2 times, and we hit the URL. So if we look at the URL now, the response, yes, the response is coming from the pilot revision. So this is another way of hitting the tagged revisions with 0 traffic by providing the HTTP header of the knative tag, and yet to start, yes, we're getting the response now. If you're looking at this 700, why? Because we provided the, again, the wrong tag, not the pilot tag. Oh, it's empty. So if we set it back to pilot and we try again, we can see that we're able to hit the revision 4 that was tagged as pilot.